Now, the other thing we've been learning about recently that is going to be around for the rest of the year, so hopefully you already have perpendicular lines in your glossary, but we want to see how does perpendicular lines come into our statement reason tables. That's what this little upside down T means. This means that line segment AB is perpendicular to AC. And from our glossary, we know that perpendicular lines, when they hit each other, they always make 90-degree right angles. That's the key understanding we need when we talk about perpendicular lines. So let's draw it out. Line segment AB is perpendicular to line segment AC. Now, since they both have A in common, the other line is going to start and go down to C. So we have AB and we see AC. And since they're perpendicular, we automatically know that wherever they intersect creates a 90-degree right angle. Automatically, we know that's 90 degrees. So let's draw our other shape down here. JK, not kidding though, is perpendicular to KM. So we're going to draw JK. And I see LM. They have K in common, so that's where they're going to intersect with each other. So I'm going to start at K and go down to M. And once again, the automatic knowledge we get from perpendicular lines is wherever they intersected, we automatically know there's a 90-degree right angle there. So what does this look like with a statement and a reason? When we see that two perpendicular lines, even if they're different sets, they always make a 90-degree angle. So we automatically know that angle A is 90 degrees and angle K is 90 degrees. So they're the same thing. So we can say that angle A is congruent to angle K. And why did we know that? Well, it was literally from the definition of perpendicular lines. They always make 90-degree right angles. Every time two perpendicular lines hit, 90 degrees, 90 degrees. So we know that those 90-degree angles are congruent, and we know that because our definition of perpendicular lines.
Okay, so now we need to take what Mr. Bakke was talking about and include that in a proof, right? What does that look like when we're proving that two triangles are the same, not just two angles? So this is the problem that we're going to take a look at. We're given a bunch of information up here, right? It tells us AB and ED are the same. We got a midpoint. We got some perpendicular stuff going on. And then down here it asks us to prove that this triangle here and this triangle here are the same, okay? So let's start with the easiest part. We know we're going to make a statement reason table. Okay, and the first thing given to me in my statement reason table is that AB and ED are the same, right? So AB and ED, we can just put that straight into our table. AB is congruent with ED, right? And that was just given to us, so we're just going to write given. Okay, and this is where this problem gets a little bit trickier. Okay, the next part says C is the midpoint of BD. Okay, so if we think about midpoints and what we know about midpoints, if this is line BD, and we add a midpoint, C, right? We know that this midpoint has to be right in the middle, which means that these parts on either side are the same, okay? So take that thinking and just bring it down to your shape, right? Same thing here. If C is the midpoint, that means that those sides on either side are the same. So what we can say in our table is that BC is congruent with CD. And we know that because we know what a midpoint is, okay? So we can say definition of midpoint. Okay, but we're still not quite done. This is only two things, and like Mr. Bakke likes to say, if we want to use triangle law, we need three things. So let's keep reading, okay? We use this one. Now let's take a look at this last statement. It says AB is perpendicular to BD. So let's find AB. Here's AB. And BD is this line that goes all the way across the bottom. It says that they're perpendicular, which means they have to meet at a 90-degree angle. Okay, so we can just mark that with a little right triangle. And now let's look. The next thing it says is ED and BD are also perpendicular. BD, once again, is the line on the bottom, and ED is over here. So we've got another 90-degree angle. Okay, this one's 90, this one's 90. 90 and 90 are the same number, so we can say that angle B is congruent with angle D. Okay? And our reason there, it's not given, right? We had to do a little bit of thinking. We're just going to say it's the definition of perpendicular. Right? Because we knew that those are both perpendicular, we know that those angles are the same. Okay? Now I've got 1, 2, 3 things, so I can use my triangle law. When I look here, I've got a side, I've got an angle in between, and another side. So I would use the SAS proof here. Okay, and we're going to name our triangles same as we always do. Triangle A, B, C. I went down the side with 2 black markings, across the side with 2 green markings. So I would say ABC is congruent with EDC. And we're done.